Gottfried Wilhelm Leibniz. A presentation in 6 slides. The early life of Gottfried Wilhelm Leibniz he was born in Leipzig, Germany in 1646. That's the 17th century. His father was a professor of philosophy at the university in Leipzig. He died when poor Leibniz was only about 6 years old. Imagine losing your father at the age of 6. Brings a tear to my eye. Leibniz, however, took after his father in his scholastic pursuits, going in Daddy's footsteps, learning about philosophy, in addition to Greek, Latin, theology, and law. He applied for the doctorate of law from the university in Leipzig when he was 21 years old. And here you can see I have a picture of Leibniz. He has more hair than my great-aunt Ruth's wig. Later life. Having been denied the law doctorate in Leipzig by jealous university professors, Leibniz moved to Altdorf, also in Germany, where he was finally granted his degree. From Altdorf, Leibniz moved to Nuremberg, from Nuremberg to Paris, now that's France, and following him from there to Brunswick, eventually entering into the service of the Hanoverian family in Hanover. This is where he finally had the free time to invent calculus, which is often considered to be his greatest contribution to the modern era. And here we have the coat of arms of Hanover, which was a very important place in Leibniz's life. Again, it's where he was able to finally take the time to invent calculus. There's lions and a harp and lots of stuff, courtesy of Google. Leibniz's calculus notation. The notation of Leibniz's calculus is as follows, courtesy of A. Rupert Hall's book, Philosophers at War. Check your local library. dx, he, that is Leibniz, said, is the difference between two closely related values of any changing quantity x and a dy, the corresponding change produced in the second variable y, which is related to x by some mathematical expression. Then, if dx is constant, dy will define the slope of the tangent as x. Leibniz showed in rather detailed steps how this could be worked out when applied to a curve, whose shape was defined by some algebraic expression, arguing rather naively, as Newton sometimes did, that though a product such as x times dx was not negligible in quantity, the product of two infinitesimals, that is, dx squared or dy squared, was too tiny and could be ignored. Thus, he could demonstrate that dx squared equals 2x times dx. Leibniz versus Newton. Leibniz was consequently dragged into an international dispute with Isaac Newton, who also claimed to have invented calculus. Nothing like a good scandal. In Newton's favor, historical facts show that he did, in fact, come up with calculus first. Now, it's often thought that Leibniz took away some of the ideas of Newton's calculus when he was on a trip to London from Hanover. In Leibniz's favor, his notation was far more detailed than Newton's, and he published his work first. So there is verifiable evidence for Leibniz before there is for Newton. This is a picture of Isaac Newton. I guess he was just jealous of Leibniz's hair. I mean, look at this. It's paltry compared to what we saw of Leibniz before. The conclusion. Yes, we're finally at the end. Despite Leibniz's faults and his failure to gain any lasting favor in the courts of Europe, the legacy of his calculus notation has proven invaluable to mathematicians. In my opinion, Leibniz was the greater of the two mathematicians. He was also a great philosopher, something which Newton, frankly, cannot match. And here I have a picture of a little Gottfried Wilhelm Leibniz mug, and the caption here says, "Here's to Leibniz, a great mathematician, politician, lawyer, and philosopher." The end.